Aim of the experiment to study the variation of resistivity of a germanium crystal with temperature by 4 probe method. Now, this is a virtual setup for 4 probe method. The experimental setup consists of probe arrangement, sample, O1, constant current generator, O1 power supply and digital panel meter. 4 probe apparatus is one of the standard and most widely used apparatus for the measurement of resistivity of semiconductor. This method is employed when the sample is in the form of thin wafer, such as a thin semiconductor material deposit on the substrate. The sample is millimeter in size and have a thickness W. It consists of 4 probe arrangement linearly in a straight line at equal distance as from each other. A constant current is passed through the 2 probes and the potential drop V across the middle 2 probes is measured. An oven is provided with a heater to heat the sample so that the behavior of the sample is studied with increase in temperature. We will discuss it in detail in the procedure part. As we know, conductivity of a semiconductor material is very sensitive to temperature. With increase in temperature, the number of electrons available for conduction increases. This leads to the increase in conductivity. Resistivity of semiconductor have negative temperature coefficient. This is the whole setup for 4 probe method is given. We know that the resistivity of semiconductor decreases with increase in temperature, and here we will be measuring the resistivity with change in temperature. So for that we require an oven. This black part which we are seeing here, it is our oven, and this metallic body on the top, it is our 4 probe arrangement. If I click on cross section, we can see this 4 probe arrangement. So very thin 4 probes are there which are touching the sample, and in these 4 probes the sample which we use, it is usually in the form of wafers. Here we have 4 probes, probe 1, probe 2, probe 3 and probe 4. So probe 1 and probe 4 are the outermost probe which will be carrying the current, and probe 2 and probe 3 are the innermost probe and measures the voltage. So now we can see it is our PID controlled oven. So here we can change and control the temperature. It is our constant current source and it is our voltmeter. So the current in this experiment will be kept constant, and here the voltage will change with change in temperature. And we have to note down the voltage reading. So before starting the experiment, we will set some parameter. Here in the select material, we have two materials, germanium and silicon. For now I will go for germanium, and then we have a tab of range of current, and we will take it as 20 milliampere only. Right now the current tab is at 1 milliampere and we can change it. So for now I will set it as 10 milliampere. Now throughout the experiment the current will not be changed. Here we have 4 tabs: set, run, measure and wait. These tabs will be used to performing the experiment. So here I will set the temperature, and the temperature is range from 25 degrees Celsius to 95 degrees Celsius. Now we will click on set and the temperature range is varying. Now we will click on run and we will see here the temperature will start increasing, and we will note down the readings of voltmeter at the difference of 5 degrees Celsius up to 95 degree. Once we recorded the value by using formula, we can calculate the resistivity and plot curve between resistivity and temperature. And the same procedure is followed for other material also. And this is the observation table, and by performing the experiment we have measures the reading. And this is the resistivity versus temperature curve, and as we already know, the resistivity of semiconductor decreases with increase in temperature. At last we concluded that variation of resistivity with temperature was successfully studied for germanium crystal using 4 probe method. And it was observed that the resistivity of semiconductor material decreases with increase in temperature. Thank you.